You know, we spend so much time trying to make sense of the past, but what if we could get a little bit better at predicting the future? Well, that's what we're diving into today, the mathematics of chance. It's this powerful tool that helps us calculate the odds of what's to come, from something as simple as a coin flip to the biggest decisions we make in our lives.
So here's the plan. We're going to start with a pretty surprising question about everyday risk. Then we'll look at the three main ways we can actually calculate probability. After that, we'll uncover how some simple rules can lead to some really shocking results, learn a great shortcut for counting up all the possibilities, and finally, bring it all home to see how this stuff applies in your world.
Let's be honest, we're all a little obsessed with chance, right? We talk about the odds of winning the lottery, the chances it's going to rain, or the risk of some new investment. But how good are we really at judging those risks? Let's put our intuition to the test.
Okay, picture this. You're hopping in the car to go to the store. It's just a short trip, maybe a 2-mile round trip, and you're going to buy a Powerball ticket. Your mind is on that huge jackpot. But there's another potential outcome of that drive, a much, much less pleasant one. So the question is, which of those two things is actually more likely to happen?
All right, so the answer? It is not even close, not by a long shot. The data shows you are more than 4 times more likely to be in a fatal car accident on that short trip than you are to win the Powerball. And this just highlights a really critical point. Understanding probability isn't just for a math class. It's absolutely essential for navigating the real risks we face every single day.
So, if our gut feelings about risk can be that far off, how do we get more precise? How do we actually put a number on uncertainty? Well, it turns out there are 3 main ways to do it. Let's break them down.
Okay, first up is what's called the classical approach. This is the one you probably remember from school. Think about rolling a standard die. You've got 6 sides and each one is equally likely to land face up. So the probability of rolling, say, a 4 is just one favorable outcome out of 6 total outcomes. It's simple, it's clean, and it's based on just the pure logic of the situation.
A perfect real-world example is a pick 3 lottery. Every single number, from 000 all the way to 999, is a possible outcome. That gives us exactly 1,000 possibilities. So if you have 1 ticket, your probability of winning is 1 out of 1,000. Simple as that. But of course, not everything is as neat as a dice roll, right? What happens when the outcomes aren't equally likely? Well, that's where empirical probability comes in. Instead of just using theory, we look at history. We look at what has actually happened in the past to help us predict what might happen next. It's all about using real-world data.
Let's talk about a real pro, like NBA superstar Stephen Curry. In one season, he made 278 out of 302 free throws he attempted. So based on that data, what's the probability he makes his next one? Well, you just take the number he made, divide it by the number he took, and bam, you get 0.92. We're just using his past performance to estimate his future success.
And that brings us to our third type, subjective probability. So what do you do when you don't have a perfect theory and you don't have a mountain of historical data? You have to make an educated guess. This is just an estimate based on your experience, your gut, and whatever information you do have. It's your best judgment call when you're facing the unknown.
Okay, so now we know how to put a number on chance. But this is where it gets really fun and kind of weird. When you start combining probabilities, simple rules can lead to results that feel completely wrong, but are mathematically absolutely true.
All right, I've got a classic brain teaser for you. Get ready for this. Imagine you're in a room with just 30 people. What do you think the chances are that at least 2 of them share the exact same birthday? I'm not talking about the year, just the month and the day. Go on, take a guess. 10%? Maybe 20?
Get this, the answer is over 70%, 0.706. With just 30 people, it's way more likely than not that you'll have a birthday match. Isn't that wild? It's a perfect example of how our gut feelings about probability can be so wrong. And it gets even crazier. You only need 23 people for it to be a 50-50 shot. So how on earth is that possible? Well, it's because we're not looking for one specific birthday. The number of possible pairs of people in that room grows incredibly fast. The secret is a little math trick. Instead of trying to find the odds of a match, it's actually way easier to calculate the odds of no one having a match, and then just subtract that from 1. The result is undeniable, even if it feels totally bizarre.
So you can see how a huge piece of this probability puzzle is just figuring out the total number of possible outcomes, which, as you can imagine from the birthday problem, can get really complicated really fast. Sure, for a coin flip, it's easy, but for more complex stuff, counting every single possibility would be a total nightmare. Thankfully, there's a shortcut.
And that's where something called the multiplication formula comes in. It's super simple, but honestly, it's a total game changer. All it says is if you have a series of independent choices, you just multiply the number of options at each step, and that gives you the total number of combinations.
Let's make this real with an example we can all understand. Blood types. When we classify blood, there are basically two separate steps. First, there's the blood group. You've got 4 possibilities there: A, B, AB, or O. Then there's the RH factor, which is either positive or negative.
So how many total blood types are there? We just use the formula. 4 options for the blood group times 2 options for the RH factor gives us a grand total of 8 possible blood types. The formula gives us the answer in a split second. No need to count them all out one by one. All right, so we've covered a lot of ground, right? From that shocking lottery ticket fact to a super simple formula for counting. But the real goal here isn't just to talk about math theory. It's about using these ideas to make better decisions in our own lives. So if you take away just a few things from all this, let it be these. Probability is basically a tool for measuring uncertainty. Its simple rules can show us surprising truths that our brains just completely miss, like that birthday problem. And once you have a handle on these concepts, it helps you understand risk way more clearly, which in the end empowers you to make smarter, more informed decisions every single day.
So I'm going to leave you with a final thought. Whether you're thinking about your career, your health, or your finances, you're navigating odds all the time. Now that you have a better feel for the tools, what are the odds in your own life that you're going to try and figure out next? Thanks for joining this explainer.